Hey everybody, welcome to Module 2. In this module, we will look at graphical summaries of data, something that's very important considering that a picture is extremely effective at conveying what's happening in statistics. Now, we're going to have a number of tools at our disposal for displaying our data. We'll look at the graphing calculator and Connect Math, and we'll also talk about Microsoft Excel, and I encourage you to experiment displaying data in other programs as well. The challenge in this module is not so much the display of the data or even interpreting what you see in that picture. The challenge is the vocabulary that's many times attached to what we're doing. You'll see that right away in this first video, but hopefully I can show you that there's always a simple way to think about the vocab. Okay, so let's get started. So our focus here is a graphical summary of qualitative data. So I have an example where I have a qualitative variable, which is level of education. That's also an ordinal qualitative variable. And I collected some data from a recent class of mine, and when I asked my students, what is the highest level of education that you plan on pursuing? 12 people said that they would pursue a bachelor's, 9 said that they would pursue a master's, 3 said that the highest level would be associates, and 6 said some sort of a doctorate. So this is simply a table of counts, isn't it? But we give it a name in statistics that's pretty formal. We say that this is known as a frequency distribution. And since we're working with qualitative data, this is actually a frequency distribution for qualitative data, for our qualitative variable of level of education. And you can see that the word distribution applies because we're seeing how the data are distributed among the different categories. Now, many times when we look at a frequency distribution, we're also interested in a relative frequency distribution. A relative frequency distribution is a little bit different in the sense that instead of looking at frequencies, we look at relative frequencies or percentages within each category. So a relative frequency distribution is a table of percentages versus a frequency distribution being a table of counts. Now, how do we get the percentage of people that said in my class they are going to pursue a bachelor's? Well, you take this number and you divide it by the total. So if we just said 12 divided by the grand total here, then that is going to give us the relative frequency, or the percentage of people that picked this particular category. So if you come over here, 12 divided by 30, we could see is equal to 40%. So 40% of the people in that class said that they would pursue a bachelor's as the highest level of education. If we do 9 divided by 30, or 3 divided by 30, and 6 divided by 30, we can get our other percentages. And so let's do those real quickly. So 9 divided by 30 is equal to 0.3. 3 divided by 30 is 0.1. And then 6 divided by 30 you would see is 0.2. All of these relative frequencies are going to add up to 1. That's our total. Just like all of these counts added up to the total number of people in the class. So what do we do with either a frequency distribution of qualitative data like we have here, or a relative frequency distribution? Like I was saying, we want to graphically summarize that. So down here, we could sketch this out. We could say, okay, well, a bachelor's category is going to go up to 12. This is going to be my frequency bar graph right here. So let me label that. This is my frequency bar graph. And then this one is going to be my relative frequency bar graph. Relative frequency bar graph. Okay, so bachelor's goes all the way up to 12. And so I would have a bar for the bachelor's category, and I'm going to leave a little bit of space in between each one. Master's goes up to 9. Associates goes up to 3. And doctorate goes up to 6. So this is a nice display of this data, and many times the story is told a little bit more effectively with this picture than it is with this table. Likewise, we could tell the same story with a relative frequency bar graph. But what you're going to notice is it really is the same story. Watch this. So the bachelor's goes up to 40%, so that'd be 0.4. Master's goes up to 0.3. Associate's 0.1. And doctorate 0.2. Don't those graphs tell the exact same story? Isn't it the same relationship that the bars all have among each other in this picture or in this picture? And for that reason, sometimes we see frequency bar graphs and sometimes we see relative frequency bar graphs. The reality of it is, though, you are never going to construct these by hand, both in this class and in any other class or in practice. It's actually pretty common to do this type of thing in Microsoft Excel. So let me just show you how this example would apply to Microsoft Excel. So I've entered our data in here. You can see bachelor's at 12, master's 9, associate's 3, doctorate 6. And all you need to do if you want to visualize this in Excel with a bar graph is you could select or highlight what you want to exist in your bar graph, and you would go to Insert at the top of the page, and when you press Insert, you'll see all of these choices. And so I can click on a bar graph, and it says I can do a 2-dimensional bar graph or a 3-dimensional one. Let's just keep it simple there. And you can see that I now have a 2-dimensional bar graph, and this looks identical to what we were just doing by hand. But obviously it's much nicer looking, and this is what you could embed into reports or presentations if you ever wanted to produce your own bar graph. Now sometimes it's useful to take the information that you have in this distribution and condense it into a single graphic known as a pie chart. And a pie chart is something that we can easily create in Excel as well. We would simply highlight our columns of interest, go to Insert once again, and underneath the bar graph, select either 2-dimensional or 3-dimensional pie chart, and there it is. Now, to create a pie chart, there's a little bit more that's going on, because these aren't simply numbers that you have in each section of the pie graph. What's happening is these numbers are converted into their relative frequencies, which we already looked at in the notes, and then those relative frequencies are eventually converted into a certain number of degrees around the circle. And that's how Excel knows how to make the blue section this big and how to make the orange section this big, etc. It uses the fact that there are 360 degrees in a circle, and we figure out how many degrees are going to go to each category. But the nice thing is for you really don't have to worry about that so much as you need to worry about interpreting what we're doing and what we're coming up with here. So let's take a look at Connect now and see how we would do a couple of similar types of problems in your homework. So here's an example that says, hospital admissions. The following frequency distribution presents the 5 most frequent reasons for hospital admissions in U.S. community hospitals in a recent year. So we have 86,000 people are admitted for congestive heart failure, 126,000 for atherosclerosis, 58,000 for heart attack, 311,000 for birth, 103,000 for pneumonia. And so you can see here it says drag bar to change the value, and when I hover over it, this finger appears, and then if I just click and drag, then you can see that I can go up to whatever I need to go up to. And in this case, I want to go all the way up to 86, and so I try to land on 86, and it can be a bit of a pain to land directly on the number. And so as a result, you also have the option of just going into that rectangle there and typing the number that you want, and it takes you exactly to where you need to go right away. 126 for that second one, heart attack 58. It's probably the quickest way to do this. So make sure to use those shortcuts. Infant birth 311 and pneumonia at 103. So you can kind of see the distribution here, and you do notice in this distribution that the bars are going sideways. That's completely fine. You can tell your story with sideways bars, or you can tell the story with vertical bars. It really doesn't make a difference. It's still going to be the exact same relationship, the exact same distribution. Okay, let's take a look at a pie chart now in Connect. Okay, and here's another problem that relates to the hospital admissions. We've got some different data here, and you can see if I scroll down, there's our pie chart. What Connect is going to prompt you for is the relative frequency or the percentage for each category. And so this is a little bit different than what we just saw in Excel. In Excel, we just highlighted everything and it did it all for us. We have a little bit more work to do here. Basically, what we need to do is we need to convert all of these frequencies into relative frequencies or percentages so that we can enter those percentages below. And so let's first find the grand total of all of these numbers. And that way we will have our denominator for computing all of the relative frequencies. So we have 920 plus 1250 plus 620 plus 1064 and 3720. And we get a grand total of 7,574. So we could say 920 divided by 7,574, and we get a little over 12%. You'll notice when you're using the pie chart tool, construct a pie chart where we round answers to the nearest whole percent. So to the nearest whole percent, this is 0.12 or 12%. So when I'm entering my answer in Connect, I would come over here and say 12 for 12%. If I did 1250 divided by 7,574 again, I end up getting 16.5%. So I would round to the nearest whole percent, and that again would be 17% in this case. And you could see that after you click on it, the program in Connect takes care of the shading on its own. Next one is heart attack, so you would say 620 divided by 7,574, and we end up with a little over 8%, but rounded to the nearest whole percent, that would be 8%. And again, the graph adjusts. Pneumonia, 1,064 divided by 7,574, and we end up with a little over 14%. So we can come down here and just say 14, enter. And then our very last one, 3,720 for infant birth. And so 3,720 divided by 7,574, you can see it's going to be almost 50%. It ends up being 49%. So when we put this last one in, it should finish our pie graph. And there it is. So that's how you're going to be doing this in Connect. That's, again, that's how we did a little bit differently in Excel. And it's going to be a little bit different with your syntax or however you set it up in any type of program. But the fact of the matter is it's pretty easy to come up with these displays, and then you can use these displays in your presentations, reports, and it's a much easier way to convey what's happening. Okay, so now we're ready to take a look at displays for quantitative data, and you'll catch that in the very next video. Check it out.